Section 4.1 on radian and degree measures. This is going to be the first section in Chapter 4, starting our trigonometry. So we're going to learn how to measure angles using two different types of measurements, radians and degrees. So let's start by looking at the coordinate plane and let's define an angle. So an angle starts with one ray called the initial side and another ray, the terminal side, that meet at a common point called the vertex. So the angle itself is the space in between those two rays. That's what we wind up measuring, the space between initial and terminal side. Now when this angle is sitting on the positive x-axis, where the initial side is on the positive x-axis, then that angle is said to be in standard position. Okay, so there's two different ways to measure an angle, a positive angle or a negative angle. So the way that this angle is sitting on the coordinate plane right now, when I'm measuring counterclockwise, then I would give it a positive measurement, whether it's degrees or radians that we'll learn about in a minute. But counterclockwise is a positive angle. So if I measured this angle going clockwise, I would use a negative measurement, either radians or degrees. Okay, there's coterminal angles, are two angles that share a terminal and an initial side. So if I have angle A sitting out here somewhere on the coordinate plane, then another angle that's coterminal with it is going to share those rays. Okay, so angle B has the same initial side and terminal side. They share those two rays, so they are said to be coterminal. And if you notice, putting these two angles together kind of makes a circle. So that means that coterminal angles are going to add to equal 360 degrees. Okay, so let's talk about degrees. We're going to start by saying that the positive x-axis is 0 degrees. Straight up is going to be 90 degrees. We know that a right angle is 90 degrees. So opposite from 0 is going to be 180 degrees. Straight down will be 270, and then all the way back around a circle we know is 360 degrees. So these are measurements that we're comfortable with. We learned in geometry how to measure angles in degrees. Well, there's another measurement that we use in trigonometry called a radian. So we're going to look at how a radian comes about and how we can equate radians and degrees together. Okay, so let's start with those same measurements on the coordinate plane, and I'm going to throw a circle on this coordinate plane. We know that the distance around a circle is circumference, and circumference can be found by multiplying 2 pi times the radius. So let's say that the radius of my circle is 1, and if I plug that into the formula, 2 pi times 1 is going to equal 2 pi. So that means the distance around this circle is 2 pi radians. So over here where it has 0 degrees and 360, I'm going to put 0 radians and 2 pi radians. So 0 and 0 are the same. 360 we know is all the way around the circle in degrees. 2 pi radians is all the way around the circle in radians. Okay, so let's kind of break up our coordinate plane in radians now. So if we know that all the way around is 2 pi radians, then halfway around is going to be pi radians. Okay, so 180 and pi are the same. Okay, so then going up to 90, I know that 90 is half of 180, so if I cut pi in half, that's going to be pi over 2. So 90 and pi over 2 are the same measurement. Then if I go down to 270, that's like one half of the circle and another quarter of the circle. So what we need to do, this is going to be 3 pi over 2 radians, or 1.5 pi's if you think of it that way. And then back around the circle would be 2 pi. So let's see how to convert between radians and degrees. So I just said that 360 degrees is equal to 2 pi radians. Well, I want to know how much 1 radian is equal to. So I'm going to divide both sides by 2 pi. Okay, so 2 pi divided by 2 pi is going to be 1 radian. 360 divided by 2 pi is going to be 180 over pi. So 1 radian is equal to 180 degrees over pi. So if I want to convert from radians to degrees, then I'm going to multiply by 180 over pi. Okay, now let's think of it the other way. So starting again with 360 degrees equals 2 pi radians. I'm going to divide by 360 on both sides this time because I want to know how much 1 degree is equal to. So 1 degree is going to be equal to 2 over 360 is going to reduce to pi over 180. Okay, so 1 degree is equal to pi over 180 radians. So if I want to convert from degrees to radians, then I'm going to multiply by pi over 180. Okay, these conversions are very important to us in trigonometry, so you need to remember how to convert between the two. Okay, so let's look at some useful formulas that we're going to use in this section. So starting with the arc length of a circle. So if you remember from geometry, arc length is the length of an arc on a circle, like the crust of the pizza. So S is arc length equals the radius of the circle times the angle measure of the arc. Now our angle measures for arc length are going to be measured in radians. So it's going to be the radius times the measure of the angle in radians. Next is the area of a sector. A sector is like a slice of the pizza, the whole slice. So the area is equal to 1/2 the radius squared times the measure of the angle in radians again. So keep in mind both of these are measured in radians. Okay, last thing we're going to look at degree notation. Most of the time in geometry when we're measuring angles, we would just measure it in a whole number, or we might say a decimal, but it might be like 0.5. So there's another measurement that we use called degrees, minutes, seconds, and it's just a more exact way of measuring an angle, just a different notation. So it might look something like this: 34 degrees, 30 minutes, and 30 seconds. So you can think of this, the minutes and seconds on a clock. There are 60 minutes on a clock, and then for seconds, there would be 3,600 seconds going once around the clock. So if I'm going to convert from degrees, minutes, seconds to just a decimal degree, this is how I would do that. So I'm going to do the 34 degrees plus 30 over 60 minutes plus 30 over 3,600 seconds. And once I type that in my calculator, it's going to give me a decimal degree. And so it would equal 34.5083 degrees. So it's just another way to represent an angle, more precise way instead of using a decimal.